everyone, and welcome to DeCrypt's Deep Learning playlist. Today, we'll be introducing all of you to a very popular topic in deep learning, something used extensively in image recognition. That is the convolutional neural network, also called the CNNs. What is a convolutional neural network? Here we see a term that you may be unfamiliar with, that is the convolution. Convolution is a mathematical operation performed on matrices and forms the basis for this sort of a neural network. We'll get into the details of this operation eventually. The picture here sort of represents how an input image is recognized by our neural network. The input image passes through multiple convolution layers, eventually goes into a fully connected layer, and finally activates a particular neuron, which helps us make a prediction. In our case, this network, if trained correctly, will activate the neuron corresponding to 2 the most and will help give us an accurate prediction. We'll get into the details of this eventually in the playlist. Now, why a CNN? Why not use the earlier multi-perceptron structure we are already familiar with? To understand that, we have to first understand the way an image is represented by a computer. Each image is divided into very small segments called a pixel, and the number on each pixel represents the activation of that pixel and how much of it is being displayed on the computer. For colored images, you have 3 such channels for the red, green, and blue colors respectively. For black and white images, you'd have just a single channel. A picture consists of a lot of pixels. And if it's a colored image, it will consist of 3 such channels, with each channel having that many pixels each. Which means weights for each of those pixels, and it becomes infeasible real quick. And we start dealing with numbers greater than, let's say, 100,000. Another problem is multi-layer perceptrons react differently to shifted versions of the same picture. Another issue is spatial information is lost when images are flattened out. Now, this is the convolution operation we had talked about earlier. The way it works is, we have square matrices called filters. In our case, it's this yellow 3x3 matrix that moves around our input image and performs an operation called the convolution. What we're doing here is multiplying each square of the filter with the respective tiny square of the input 5x5 image and adding all of them up. That ends up becoming 1 pixel value in the convolved feature. This is repeated for the entire input image and gives us our convolved output. Now, filters are square matrices with predetermined weights that help filter out different structures of our input image. It could be something that helps detect vertical lines, or it could be a filter that helps detect horizontal lines. Both these filters would have different weights. Now, a filter weights need not be always predetermined. It could even be learned by our model. Now, this brings us to the end of our first video. Continue on to the next video in our playlist to keep learning about CNNs.